You know, usually when we talk about a medical diagnosis, there's this expectation of precision.
Right.
It feels very engineering focused. Like you fall down, your arm hurts, you get an X-ray.
Yeah, exactly.
And that X-ray shows a jagged white line across the bone, and the doctor just points at it and says, there it is.
It's entirely binary. I mean, the bone is definitively broken or it is not.
Right. Broken or not broken. It's clean, it's categorized, and honestly, it's kind of comforting. We like our problems to be visible.
Oh, absolutely. But step out of that binary world and into something like, say, neurodevelopment or, complex immune disorders. Suddenly that X-ray machine is just useless.
Right.
You find yourself looking at a diagnostic landscape that is incredibly murky. I mean, you end up staring at shadows, analyzing the spaces between the information, just sort of trying to piece together the shape of the problem based on, well, what isn't there?
You're trying to diagnose the invisible.
Exactly.
And I was actually thinking about that exact metaphor today because it perfectly captures what is happening right now in the world of enterprise technology. We are taking a deep dive today into something that is entirely invisible to the naked eye, yet it possesses this crushing, massive physical weight that is just dragging down global business.
We are talking about dark data.
Yes. Dark data. And we have a really fascinating mission for this deep dive. We are going to apply the philosophy of the legendary industrial designer Dieter Rams to this totally invisible problem.
Which is brilliant, because Rams is famous for his ethos of, less but better.
Less but better. I love that.
Right. It is a philosophy built entirely around functional clarity and reduction. So taking that incredibly rigorous physical design thinking and forcing it onto massive, sprawling, messy enterprise data architecture.
It's a brilliant collision of disciplines.
It really is.
And we are pulling from an incredible stack of sources to do this for you today. We've got statistical reports from DataStack Hub tracking the sheer volume of this issue through 2025 and 2026.
Yeah, the numbers are wild.
They really are. We've also got foundational definitions from Wikipedia to just keep us grounded. We are looking at analytical frameworks from enterprise data management platforms, specifically ReadyWorks and Comprise.
Both great sources.
And this actually might be my favorite piece of the stack. We have a high signal protocol from a tech operator named Prasad Bond. It's called the Quiet Architect Protocol.
Oh, I love that one.
Right. It reads less like a theoretical white paper and much more like a field manual for surviving an operational crisis.
Because let's be real, the crisis is highly operational. And the scale of it is almost incomprehensible until you start looking at the actual physics and the economics involved.
Okay, let's unpack this. Here is the paradox we are unraveling for you today. Right now, globally, businesses are spending an estimated $350 billion every single year to power, chill, and secure digital information that absolutely no one is looking at.
Let that sink in. $350 billion.
It's staggering.
And they aren't spending that money to process the data or, run analytics on it or extract some kind of competitive value from it.
No.
They're spending that money just to keep it on life support in a dormant state.
So let's break down the mechanics of how that is even possible. Because to understand this, the very first thing we have to do is completely shatter this illusion that we all carry around with us every day. And that is the illusion of the cloud.
Oh, man, the cloud.
We use that term constantly, right? Like, I'll just save it to the cloud, or, oh, my photos are in the cloud.
Yeah, it's everywhere.
And the metaphor does exactly what it was designed by marketing departments to do. It makes us think of our data as weightless. We picture this fluffy, ethereal, zero-gravity mist just floating gently above our heads somewhere.
I mean, it is arguably one of the most successful and perhaps most deceptive marketing metaphors in the history of technology.
Deceptive is the perfect word.
Because the cloud is not in the sky. The cloud is a hyper-industrialized, aggressively physical reality located in massive, windowless concrete warehouses on the ground. Data is a physical object.
Right. It does not exist in the ether. It exists on a piece of silicon or a spinning magnetic platter.
Exactly. When you hit save on your computer or when a massive enterprise system automatically logs a transaction, a physical machine somewhere on Earth has to do physical work.
Yeah.
Like a microscopic needle literally has to magnetize a sector of a hard drive, or an electrical charge has to be trapped in a flash memory cell. That requires physical space in a server rack.
So before we get deeper into the thermodynamics of all those spinning disks, let's get our terms straight. We are talking about dark data, but what does that actually mean? Because we aren't just talking about, like, a corrupted file, are we? How are Gartner and Wikipedia defining this?
The definition is quite specific, and it's crucial to distinguish it from data that is just, formatted incorrectly. According to Gartner, and this is echoed right in the Wikipedia entry, dark data consists of the information assets that an organization collects, processes, and stores during its regular day-to-day business activities, but which it generally fails to use for any other purpose.
So an action happens in the real world, the computer records it, and then literally no one ever looks at the record again.
That's it. A customer swipes a credit card, a temperature sensor on a factory floor pings its status, a security camera records an empty hallway.
A software application writes a line of text saying it's successfully booted up.
Exactly. All of that data is captured, it is routed through the network, it lands on a storage drive in one of those massive concrete warehouses, and then
Nothing.
nothing. It sits there. It is never queried by a database.
Yeah.
It is never analyzed by a human to find a pattern. No machine learning algorithm is ever trained on it. It just goes into the dark.
It's digital exhaust, just the byproduct of the engine running.
Digital exhaust is the perfect term for it. And the sheer staggering scale of this exhaust is where the physical reality really collides with the Dieter Rams philosophy.
Right. Rams believe that good design involves as little design as possible. You strip away the non-essential so the essential can actually breathe.
Yes, but modern enterprise architecture has done the exact opposite. If you look at the DataStack Hub statistics for 2025 and 2026, they estimate that globally, 55% of all enterprise data is considered dark.
Over half. 55% of everything that every corporation, hospital, bank, and government agency goes through the trouble of saving is completely useless to them.
Completely useless.
They are paying to store a majority of nothing.
And in some sectors, the hoarding is far worse. I mean, nearly 1 in 3 organizations report that 75% or more of their stored data is dark or obsolete.
Wow.
Across all industries globally, this dark data accounts for roughly 60 zettabytes of dormant storage as of 2025.
A zettabyte. We need to ground that number because the human brain just kind of gives up when numbers get that large. It's a 1 with 21 zeros after it.
Yeah.
And we have 60 of those zettabytes, just filled with forgotten, unparsed noise.
The trajectory is so steep that the scientific community literally had to invent new words to measure it.
Wait, really?
Yes. The overall explosion of data creation is projected to hit 180 zettabytes very shortly. Because of this, over the last year, 2 entirely new units of measurement were officially introduced to the metric system.
What are they?
The Rana, which represents a number with 27 zeros, and the Quetta, which represents 30 zeros.
The era of the quettabyte. That is insane. But, the real monster here isn't the data itself. It's the physical cost of keeping that data alive. Let's go back to those concrete warehouses. Prasad Bond's quiet architect protocol refuses to let us think in abstract terms here. He forces us to look at the hardware. If I have a massive data center filled with thousands of high-density server racks storing these 60 zettabytes, what is actually happening to the ambient temperature in that room?
Well, the room is effectively turning into a massive industrial oven.
An oven?
Yeah. Electricity is flowing into the servers to spin the magnetic disks and power the processors. That electrical resistance generates a massive amount of heat. If you just leave those servers running in a closed room, the hardware will literally melt down.
Wow.
The circuit boards will warp, the solder will melt, and the data will be destroyed.
Which introduces the cooling problem.
Which introduces a monumental energy demand. You cannot let a data center overheat. So these facilities require industrial-scale HVAC systems. They call them CRAC units, computer room air conditioning. These systems pull megawatt hours from the local municipal power grid to constantly chill the air and pump it under the floorboards into the server aisles. Some modern data centers even use massive water cooling towers. You are paying a literal energy tax to fight the thermodynamics of your own digital hoarding.
And when you scale that energy tax across 55% of all the data on Earth, data that is doing absolutely nothing, you arrive at that $350 billion figure. Enterprises are spending $1/3 trillion annually to power and chill a void.
What's fascinating here is if we look at the microeconomics of a single company, the ReadyWorks data highlights that the average mid-sized enterprise spends between $1.7 to $3.3 million annually just storing and managing this dark data.
Just on the dark data.
Yeah, that is pure operational overhead. It adds roughly 30% to the cloud infrastructure bills of large corporations.
There is an incredible metric in the sources regarding Netflix. It was estimated they were spending $9.6 million a month on Amazon Web Services, AWS.
Almost $10 million every 30 days.
Yeah, and it prompted these massive internal cost control efforts. Because at a certain scale, your cloud bill stops being an IT line item and becomes an existential threat to your profit margins.
And we absolutely must look at the environmental cost of that $9.6 million bill, because all that electricity powering the serverrack units and the spinning disks has to come from somewhere.
Right.
And globally, a significant portion still comes from carbon-emitting power plants. The DataStack Hub and ReadyWorks sources point out a startling, almost unbelievable fact.
Which is?
Data centers now have a greater carbon footprint than the entire global aviation industry.
Okay, that is wild. We spend so much time feeling guilty about taking a cross-country flight because of the jet fuel emissions, but we don't think twice about leaving gigabytes of duplicated, useless files sitting in a cloud bucket for 5 years.
Exactly. That file is constantly drawing power from the grid 24 hours a day, 7 days a week.
It's just sitting there burning coal.
Yeah, pretty much. The research indicates that if organizations were to embrace DRAM's concept of functional reduction, like if they were to simply delete the obsolete, unused 55% of their storage, it could reduce total data center energy consumption and lower global carbon emissions by 15%.
15%?
Yeah. That is a massive digital decarbonization opportunity that requires no new green technology, just the willingness to press delete.
Okay, wait. Let's pause here. Because I'm looking at my own AWS bill for a little side project, and cloud storage is incredibly cheap. It's literally pennies per gigabyte.
Right.
The whole pitch of the cloud, going back 10 or 15 years, was that we wouldn't have to worry about this anymore. We outsourced the hard drives to Amazon and Microsoft and Google so we could just dump everything there cheaply. Why should a billion-dollar enterprise care about a few petabytes of cheap storage?
That is the exact trap the industry fell into, and it perfectly illustrates how the illusion of cheap microcosts blinds organizations to the macro reality. Yes, storing 1 gigabyte of data in a standard Amazon S3 bucket is pennies. The unit economics feel trivial.
It feels like renting a massive climate-controlled storage unit down the street from your house, and it only costs you $1 a day. You think, wow, what a bargain.
Yeah.
So you start filling it with broken kitchen appliances, old magazines, tangled USB cords, things you will literally never use again.
And at $1 a day, you don't feel the pain of hoarding. But enterprise data does not scale linearly. It scales exponentially. You aren't renting one storage unit, you are renting 10,000 and then 100,000.
Right.
But more importantly, the storage space itself is just the base cost. When you dump data into an enterprise cloud environment, a whole ecosystem of automated services attaches to it.
What kind of service?
First, there are replication costs. A good enterprise architecture is redundant. If you save a useless log file in a data center in Virginia, the system automatically copies it to a data center in Ohio to protect against a regional power outage.
Ah.
So now you are paying to store and cool the garbage twice. Then you have backup services taking daily snapshots of the garbage.
Oh, wow.
Then you have egress fees. The cloud providers make it very cheap to put data in, but if you ever need to move that data across the network to analyze it, they charge you a premium to move it. Finally, you have security vendors charging you by the gigabyte to scan that dark data for viruses.
It's a snowball effect.
Yeah.
A penny per gigabyte suddenly turns into a massive multi-layered service contract.
Exactly. So that cheap storage quickly scales into a $3.3 million annual overhead. The Quiet Architect Protocol makes this point forcefully.
Oh.
The C-suite incorrectly views massive data volume as a corporate asset. They view it as an intellectual property safety blanket.
Right.
But the physical data center and the VP of infrastructure, who actually pays the AWS bill, treats it as a thermal and financial liability.
Which begs a massive psychological question. If it costs $350 billion and it creates a larger carbon footprint than airplanes, and it drives up our IT bills exponentially, why do we keep it? How did we get to a point where 55% of our digital footprint is junk?
Well, it is deeply rooted in human behavioral psychology, which has been amplified by corporate anxiety.
So let's explore that hoarding instinct versus minimalist design.
Mhm.
Why does dark data accumulate at this specific rate? The sources point to a few very specific structural causes within companies,
They
right?
do. The primary driver is what the industry calls a save everything philosophy. For the last decade, the loudest mantra in the tech world was that data is the new oil.
We've all heard that one.
Right. The prevailing belief was that if you just collect every single digital breadcrumb your company generates, eventually some brilliant data scientist or some future artificial intelligence will figure out how to extract immense game-changing value from it.
It's the digital equivalent of someone holding on to a massive stack of newspapers from 1998 because you never know when there might be a clue in there. It's a false belief that all data inherently possesses intellectual property value just by existing.
And that belief creates operational paralysis.
Hmm.
Nobody wants to be the executive who deleted the file that could have been monetized.
Yeah.
But practically, how does this hoarding manifest in the network? The DataStack Hub statistics show that the #1 cause of dark data, cited by 82% of organizations, is the existence of data silos.
Okay, let's break down the architecture of a data silo. What does that actually look like under the hood?
Think about how a modern company buys software. The marketing department might buy a specialized platform to track customer engagement on the website. That platform has its own proprietary database. Meanwhile, the finance department uses a completely different software platform to track revenue, which uses its SQL database. And customer service uses a third platform to log phone calls.
And the API, the application programming interface of the marketing software isn't built to talk to the SQL database in finance.
Exactly. The
Yeah.
systems cannot communicate. The data is walled off. So marketing collects petabytes of customer interaction data. But because no one else in the company can see it or query it, its utility is artificially limited.
Right.
And when marketing eventually moves on to a new campaign or buys a new software tool, that old proprietary database is abandoned. The data just rots in the silo.
And the IT department doesn't clean it up.
They can't because they don't even know it's there.
Yeah.
The research shows that 67% of enterprises lack a unified data catalog. They literally do not have a master inventory of what digital assets they own. They are flying blind.
Wow.
Now, add employee turnover to that lack of visibility. When a software engineer or a project manager leaves a company, they leave behind all the data repositories they created.
Like their personal testing environments or, localized databases, they spun up for a specific 2-week sprint.
Precisely. The research shows that employee turnover and these decentralized storage practices contribute to 20 to 25% of all orphaned data. They are the ghost ships of the enterprise, just floating around the network, drawing power, automatically backing themselves up, belonging to someone who hasn't worked at the company since 2021.
And this chaos isn't spread evenly across the economy. When we look at specific industries and the sources, the numbers are just terrifying. Let's look at healthcare.
Healthcare is arguably the most critical sector facing this issue, and the one where the consequences of poor design are the most acute. According to the reports, up to 80% of healthcare data becomes dark data.
80%? How is that even possible? A hospital's entire function is based on accurate patient records.
It comes down to the format of the data. We are largely talking about unstructured data. Think about clinical notes typed out by a doctor during a consultation. It's a paragraph of free text, not a neat spreadsheet. Or, more significantly, massive medical imaging files. When a patient gets an MRI or a CT scan, the machine generates enormous high-resolution digital files stored in what they call PCS systems, picture archiving and communication systems.
So a patient gets the MRI, the radiologist looks at the image on their screen, makes a diagnosis, types up the free text note, and then that massive multi-gigabyte file is shoved into cold storage and never seen again.
And because of incredibly stringent compliance laws like IPA in the United States, which strictly protects patient health information, or PHI, hospitals are terrified to touch it.
Right, the legal risk.
Exactly. They don't have the IT budget to rigorously audit millions of old scans to determine what can legally be deleted. So the easiest, most legally defensible action is no action. They just keep buying more storage servers to hold images of broken bones from 10 years ago.
What about manufacturing? That's a completely different kind of data.
Manufacturing is sitting at 70% dark data. This is heavily driven by the Industrial Internet of Things, or IoT. Modern assembly lines have thousands of sensors tracking every conceivable physical metric.
Right, like a vibration sensor on a robotic arm. It generates a tiny JSON file, just a few lines of basic text saying, timestamp, temperature, vibration frequency, and it sends that payload 60 times a second.
Exactly. For one arm, that tiny text file is negligible. For a global factory footprint with 10,000 robotic arms, you are generating petabytes of text files. And the problem is 70% of that mechanical telemetry is dumped into centralized storage data lakes without ever being parsed or analyzed.
It's just a raw, continuous stream of numbers going into a void.
The energy sector has a nearly identical problem. 68% of the data collected from field sensors and neighborhood smart meters remains entirely unprocessed.
So what does this all mean? We have a physical crisis driven by a psychological hoarding instinct. This is where we need to bring in Dieter Rams. Rams is, of course, the legendary industrial designer for the German company Braun. His aesthetic and functional rigor influenced everything from the classic Braun calculator to the design of the original Apple iPod. Rams had 10 principles for good design.
And two of those principles are profoundly relevant as a cure for this enterprise disease. Principle number 3 states, good design is unobtrusive. Products fulfilling a purpose are like tools. They are neither decorative objects nor works of art. Their design should be neutral and restrained.
I love that.
And principle number 10, his most famous, good design is as little design as possible. Less, but better. It concentrates on the essential aspects, and the products are not burdened with non-essentials.
Less, but better. It is such a beautiful, clarifying mantra. I mean, think about a classic Dieter Rams Braun radio. There isn't a single unnecessary button. The dial does exactly one thing. The speaker grill is optimized purely for sound transmission. Now compare that minimalist storage design to traditional data hoarding.
Traditional data hoarding is maximalist. It is loud, it is chaotic, and it is burdensome. Storing petabytes of unparsed, unformatted application logs from 5 years ago is the IT equivalent of refusing to throw away a broken toaster. You are burdening your system with non-essentials.
It completely violates the principle of unobtrusiveness. Dark data is highly obtrusive. It clogs up search queries. Like when an employee tries to search the company intranet for a current policy, they have to sift through 15 outdated drafts from 2018.
Yes.
It slows down system migrations. It inflates the IT budget, which drains financial resources away from actual innovation.
Applying Dieter Rams to enterprise architecture means embracing functional reduction. You strip away the noise so the signal can be seen. In data terms, this means aggressive lifecycle management. If a piece of data does not serve a clear, defined, ongoing business function or meet a strict regulatory requirement, it must be removed. Less data, but better data.
So, practically speaking, what does this all mean for the actual performance of a company? If I'm a CEO and I force my IT department to clean out the digital garage, does the car actually drive faster?
Emphatically, yes. The DataStack Hub statistics reveal a powerful metric. Data-driven organizations that apply these minimalist principles and reduce their dark data footprint below 30% experience 1.8 times faster decision cycles.
Almost twice as fast to make a corporate decision? That's huge.
Because the executives and the data scientists aren't wading through swamps of irrelevant information to find an answer. Their analytical dashboards are clean. Their database queries return results instantly because the database isn't indexing millions of dead files. They have achieved functional clarity.
And there is a really fascinating concept in the Wikipedia source that explains exactly why this reduction is so necessary. It's the concept of perishable insights.
Yes, this completely destroys the data is the new oil myth. The idea that data is a fine wine that gets better with age.
Wikipedia notes that about 60% of data loses its value almost immediately. It's not a fine wine. It's a carton of milk left on the counter. It's perishable goods that rot. Let's use the real-world hypothetical they provide, like real-time geolocation offers.
It's a perfect example of perishable value. If a retail business knows, via a mobile app, that a customer is walking past their coffee shop right now, that data point is incredibly valuable in that exact second. They can instantly trigger a push notification offering a 10% discount on a latte to pull that customer inside.
But if that geolocation data point isn't processed immediately by the marketing software, if it just gets written to a log file and dumped into an S3 bucket for 3 years?
It becomes entirely worthless. Knowing the exact GPS coordinates of where a customer was standing at 2:14 p.m. 3 years ago offers absolutely zero predictive or operational value for today's inventory management. The insight perished the moment the customer walked down the street. Yet the enterprise is still paying to cool the hard drive that holds that expired coordinate.
It's madness. It's expensive, carbon-heavy madness. But as we look deeper into the sources, we have to recognize that this rotting data doesn't just sit there peacefully draining the budget. It actively becomes toxic. The operational inefficiency transforms into an existential enterprise risk. We have to talk about the $5 million liability.
Security, breaches, and unmapped PII. This is where the Chief Information Security Officer, the CISO, loses sleep. Because dark data is the ultimate unseen attack surface.
Let's lay out the reality of corporate cybersecurity right now. Nearly 70% of organizations admit they do not know what sensitive data they store or where it resides. 7 out of 10 companies are basically flying blind regarding their most dangerous digital assets.
And that danger comes in the specific form of personally identifiable information, or PII. We're talking about customer names, home addresses, social security numbers, credit card details, medical histories. When you have a save everything culture combined with those data silos we discussed earlier and no unified catalog to track it all, this PII ends up scattered across the network like landmines.
It's in Excel spreadsheets attached to emails from 2019 that are sitting in a former employee's archived inbox. It's in temporary databases set up for a marketing campaign that was never deleted. It's in plaintext chat logs.
Exactly. And because it is dark data, the security team doesn't know it exists. You cannot build firewalls or encryption protocols around a database you don't know about. You can't put a lock on a door if you don't know the room exists.
Right.
But threat actors, hackers, ransomware syndicates, are exceptionally good at finding these forgotten repositories. They deploy automated scanning tools that specifically look for the forgotten backdoor. They look for the abandoned AWS bucket that someone forgot to configure with a password.
And when they find it, the financial losses are quantifiable and devastating. Unmonitored dark data increases the average cost of a data breach by $900,000 per incident. Just the presence of unmonitored dark data adds almost $1 million to the cost of cleaning up a hack. Why is the penalty so high just for having the messy data?
Because of the forensics. If a hacker breaches a clean, minimalist, well-cataloged system built on DRAM's principles, the security team can look at the access logs and instantly see exactly what specific folder was touched and what specific files were stolen.
Yeah.
They can contain it immediately.
Makes sense.
But if a hacker breaches a swamp of dark data, the security team has to spend weeks or months doing digital archaeology. They have to hire expensive outside forensic consultants just to figure out what was in the swamp, and by extension, which customers they are legally required to notify about the breach.
And the total average cost of a data breach across the board has now reached $4.4 to $5 million. The statistics point out that 26% of data breaches in 2025 originated specifically from these forgotten or unprotected data stores. 1 in 4 major hacks happens because a company refused to throw away its digital garbage.
And beyond the hackers, you have the regulators. The regulatory nightmares surrounding unmapped PII are escalating rapidly. Frameworks like the General Data Protection Regulation, GDPR in Europe, and HIPAA in the US do not accept "we forgot the data was in that folder" as a legal defense. Under GDPR, you are legally forbidden from holding onto a European citizen's personal data longer than is strictly necessary for the original purpose it was collected.
Which means dark data is, by definition, often illegal data. You collected it for a purpose, the purpose ended 3 years ago, but you kept it anyway.
Precisely. And the penalties for holding that illegal data are absolute. The ReadyWorks source highlights a massive €1.2 billion fine with a B levied against Meta by the Irish Data Protection Commission for data transfer and governance violations. Now, Meta is a giant, and their infrastructure is infinitely complex, but this regulatory strictness scales down to smaller businesses too. The sources cite a British law firm that was fined £60,000.
£60,000 for a law firm is a massive hit to the partnership's bottom line. What was the mechanism of the failure there?
Hackers stole 32 gigabytes of personal information that the firm had not adequately secured. 32 gigabytes is nothing. You can hold that on a thumb drive attached to your keychain. You can download that on a standard home internet connection in a few minutes.
Wow.
But because it was poorly secured, unmapped data sitting in a vulnerable state, the regulatory body levied a severe penalty. It proves that holding onto expired records is financially reckless, regardless of your company's size.
When I look at this, the asymmetry of the risk is just staggering. It's like leaving your house keys under a welcome mat that you haven't used in 5 years. You always use the back door now. You forgot the front mat is even there, and you completely forgot the spare key is under it. But a burglar's going to check every single mat.
This raises an important question, right? That asymmetry is the crux of the quiet architect's argument. Prasad Bond frames this perfectly. Executives are currently risking a $5 million breach penalty to protect a digital box of obsolete 2018 receipts that provide absolutely zero business value. You are risking $5 million to protect something worth $0.
It is entirely irrational.
It is. And if you apply Dieter Rams's design philosophy here, the security solution becomes obvious. You must reduce the system to its essential components. By deleting the dark data, you instantly shrink your attack surface. You remove the key from under the forgotten welcome mat. Minimalist design and data architecture isn't just about making the database run faster. It is a profound structural security strategy. Less data equals less risk.
So we've established that hoarding this data is thermodynamically expensive, organizationally chaotic, and legally dangerous. But there is a new trend that is turning this passive hoarding into an active weapon. Companies aren't just letting this data sit in the dark anymore. They are plugging this unmapped garbage directly into their brand new artificial intelligence systems.
The AI collision. This is where the dark data problem transcends storage costs and becomes a fundamental threat to the future capability of the enterprise.
Because AI has fundamentally changed how data is accessed and utilized within a corporate network, we are moving rapidly from passive chatbots into the era of agentic AI. What does that actually mean mechanically for all this dark data?
Well, agentic AI represents a shift from passive AI, where you type a prompt into a text box and it generates an answer, to autonomous AI. An AI agent is given a high-level goal, and it autonomously navigates the enterprise network, discovering data, retrieving context, and reasoning through multiple steps to accomplish that goal without human intervention.
So if an executive tells their enterprise AI agent, draft a comprehensive report on our Q3 manufacturing efficiency compared to historical baselines, the agent goes off into the network by itself to find the data.
Exactly. And this is where the collision happens.
Yeah.
Because as we establish, 55% of that network is dark data. And dark data lacks any schema. It lacks metadata tags telling you what it is. It lacks context. So when your AI agent goes hunting for Q3 manufacturing efficiency, it doesn't just find the pristine, finalized SQL database.
Oh, no.
It finds 15 draft versions of an old report from 3 years ago. It finds an abandoned project folder from a disgruntled employee that has conflicting incorrect numbers. It finds duplicated ROT data, redundant, outdated, and trivial information.
And the AI, because it lacks the human intuition to know that the folder labeled draft final degonomestosis is garbage, just ingests all of it. It eats the garbage.
It ingests the garbage. This is the classic garbage in, garbage out problem, but at an exponential scale. When large language models, which power these agents, ingest 5-year-old application logs or obsolete research, the system fundamentally chokes.
Here's where it gets really interesting. Choking isn't just a metaphor here. It has a literal, immediate financial cost. Let's dig into the mechanics of token inferencing costs. If I'm a CFO, why am I suddenly getting a massive bill from OpenAI or Anthropic?
Because of how these models process information. When you use a modern AI model via an API, an application programming interface, you pay by the token. A token is roughly a piece of a word. The model converts text into these tokens to process them.
Okay.
The more text you feed into the model as context to help it answer your question, and the more text it generates in response, the more tokens you consume. And every single token costs a fraction of a cent.
So if my data lake is filled with unparsed dark data, and my AI agent is indiscriminately scraping that lake to find context for my Q3 report,
the agent grabs millions of words of irrelevant noise, converts them all into tokens, and sends them to the AI model.
Yeah.
You are paying premium API rates and massively higher compute costs just to process irrelevant noise. You are literally bleeding money to force an AI to read your digital garbage.
that is just brutal.
The Quiet Architect protocol is brutal on this point too. Forcing an AI model to read irrelevant data multiplies inferencing costs exponentially with zero return on investment.
And it's not just the financial cost of the tokens, right? It's the output. If this AI is scraping everything indiscriminately and it finds a 5-year-old draft of a financial report, doesn't the AI just ingest that as absolute truth? How does that affect the accuracy of the model?
Model accuracy plummets, leading to massive hallucinations.
Here.
To understand why, you have to understand the mechanism of a large language model. It isn't thinking like a human. It is using complex vector weights and probabilities to predict the next correct word based on the context it was given. If you feed it outdated, conflicting, or incorrect context, you corrupt those vector weights. The model gets confused. It will confidently present false information as fact. It will increase bias in its decision-making.
Because it's giving equal weight to the pristine database and the abandoned 2019 spreadsheet.
Exactly. And when an executive reads a hallucinated report generated by the AI and makes a bad business decision based on it, User trust is destroyed. That instantly slows down the overall adoption of AI within the company, putting them at a competitive disadvantage.
The Quiet Architect notes use this incredibly striking analogy for this exact scenario. He says that expecting an AI agent to extract value from 5-year-old application logs is exactly like expecting a box of rusted screws to fix a jet engine.
It is a visceral mechanical image, and it's entirely accurate.
You don't just fail to fix the engine, you throw rusted screws into the turbine, turn it on, and the entire system shreds itself. You actively destroy the mechanism.
And the broader tech industry is waking up to this reality. The Comprise source notes a very recent, highly influential mandate from Gartner. In their reports on building storage infrastructure for agentic AI, Gartner explicitly mandates that platforms must have integrated data intelligence.
What does that mean in practice?
They note that AI needs structured governance. It needs automated metadata tagging. It needs real-time visibility so that data is searchable, categorized, and relevant the moment the AI agent requests it.
But dark data is the exact opposite of that mandate. Dark data is, by definition, ungoverned, untagged, and invisible.
Which means dark data is fundamentally incompatible with the future of enterprise AI. You cannot build a cutting-edge autonomous intelligence system on top of an industrial landfill. You have to clean the foundation first. DRAM's functional reduction is no longer just a nice aesthetic choice for an IT department. It is a mandatory prerequisite for surviving the AI transition.
Which brings us, finally, to the cure. We have diagnosed the physics, the thermodynamics, the security failures, and the AI collision. Now, we execute the solution. We need to talk about executing the minimalist purge. How do we actually fix this using strategies, protocols, and tools?
This is where we apply the concept of restorative engineering. We are restoring sanity, safety, and capability to the infrastructure by actively imposing DRAM's principle of functional reduction. We are forcing the system to be less but better.
I want to walk step by step through Prasad Bond's 48-hour purge protocol because amidst all the high-level corporate strategy in these sources, this is the most actionable, intensely pragmatic piece of advice. He explicitly tells executives, do not hold a cross-departmental alignment meeting on data strategy. Why does he hate the strategy meeting?
Because strategy meetings yield zero physical output. In fact, they make the problem worse. Meetings just generate more dark data in the form of meeting transcripts, redundant slide decks, and endless email chains. It is the illusion of action.
So instead of a meeting, he issues a mandate to executives and infrastructure owners. Execute a 48-hour protocol. He tells them to write a Python script, specifically using the Bodo 3 library for AWS, to isolate Amazon S3 storage buckets that have been untouched for 24 months. Let's translate that for anyone who doesn't write code.
Yeah.
What is Bodo 3 and what is this script actually doing?
Bodo 3 is the official software development kit, the SDK, that allows Python code to talk directly to Amazon Web Services. It's basically a digital translator. Vonda is saying write a few lines of code that securely logs into the company's AWS account and uses an API command like s3.listObjects to scan every single digital folder, which AWS calls buckets.
And what is the script looking for?
It is checking the last modified metadata tag on every single file. The script looks for any file where that tag is older than 24 months. If a piece of machine telemetry or log file hasn't been accessed in 2 years, its perishable insight is perished. The script automatically flags it.
Then, he says, to implement automated lifecycle policies to slash operational overhead moving forward. He advises applying a strict 90-day time to live, or TTL, deletion rule on all unprocessed machine telemetry. How does a TTL rule work at the storage tier level?
A time-to-live rule is an automated, ruthless mechanism of functional reduction. You set the parameter at the infrastructure level. You say, any JSON file generated by a factory sensor is given a 90-day lifespan. When day 91 arrives, the cloud provider system automatically deletes the file. No human intervention required. No one has to remember to clean it up. The garbage takes itself out.
He is incredibly specific. Milliseconds. Why is he so obsessed with that micro-level parameter? Why does latency matter for a cleanup script?
Because he is practicing parameter engineering. By forcing the developer to write code that executes in under 200 milliseconds, he is ensuring that the code itself is stripped down, elegant, and functionally pure. Minimalist design.
Wow, that's pure RAMs.
Exactly. The code cannot be bloated with unnecessary loops or heavy dependencies. It must do exactly one thing, purge the rot, and do it instantly. It is the ultimate expression of DRAMs in a digital format.
He also advises the engineer to send a 150-word asynchronous brief to the chief data officer demanding a binary yes or no to deploy the script in production. No, maybe, no, let's discuss this in Q4. It's an aggressive intervention designed to deliberately bypass the psychological hoarding instinct.
And while Bond's Python protocol is excellent for raw cloud storage environments, there are broader technological interventions required for massive, complex enterprise environments that span multiple clouds and on-premise data centers. Organizations can't just run Python scripts everywhere. They need specialized platforms that embody this minimalist design thinking.
The sources mention a few of these platforms. Let's look at the mechanics of AI-driven discovery first.
The DataStack Hub statistics point out that AI-based data discovery tools can identify up to 85% of dark data sources within an enterprise network. These are automated crawlers that navigate the network, shining a light into the silos, reading the file extensions, and mapping the topography of the swamp.
Then there are digital platform conductors, or DPCs. The source material highlights a platform called ReadyWorks as an example of a DPC. How does a DPC help an organization achieve functional reduction?
Well, a digital platform conductor acts as the central nervous system for IT management. It connects to all the disparate point solutions and systems of record. You know, the marketing silo, the finance silo, the HR silo. It breaks down the walls.
Right.
It maps data tags and uses cross-tool automation to identify which assets are orphaned. It gives the organization a single, unified view of its entire data landscape, allowing them to easily identify which files have no assigned owner or haven't been touched in years.
It's like finally turning the overhead lights on in that massive storage unit so you can see exactly where all the broken toasters and tangled USB cords are.
Precisely. And once the lights are on, you need a way to process what you see. That brings us to platforms like Comprise Intelligent Data Management, which operates at a deeply technical level across network-attached storage and object stores.
Comprise seems heavily focused on metadata. Why is metadata the secret weapon here?
Because metadata is the key to context. Data without metadata is just noise. It's the rusted screws. Metadata is data about data. It tells you who created it, when, what format it is, and what project it belongs to.
Got it.
Comprise uses a global metadatabase to index everything across the enterprise. But more importantly, they have a tool called Kappa Data Services, which extracts rich semantic metadata from unstructured files.
Let's use the healthcare example from earlier to explain how Kappa works. How does it deal with an 80% dark data swamp of medical imaging?
If you have millions of unmapped MRI scans sitting in a data lake, Kappa can automatically crawl those files and extract the DICOM headers. DICOM is the standard format for medical imaging, and the header is a chunk of text embedded in the file that contains the metadata.
So it reads the header without needing to open the whole massive file.
Yes, Kappa pulls out the patient ID, the date of the scan, the type of machine used, and the body part scanned. It takes this massive, unstructured blob of pixels and turns it into neatly categorized, highly searchable text information. It literally turns dark data into light data.
And they also use something called transparent file tables. How does that bridge the gap for data scientists?
Transparent file tables act as a bridge between messy, unstructured file storage and modern structured data lakehouses. Instead of forcing a data scientist to move petabytes of heavy image files into a database just to see what they are, which costs a fortune in egress fees, the transparent file table exposes the metadata directly to the data scientists.
That's smart.
Yeah, they can run SQL queries on the metadata before moving the actual heavy files. It is an incredibly efficient, minimalist way to manage data logistics. You only move the specific files you actually need.
And the business opportunity of doing this correctly is staggering. By illuminating dark data and running it through these governance protocols, organizations can filter out more than 70% of data noise before it ever hits an AI pipeline.
Which means you save massive amounts of money on token inferencing costs, and you dramatically improve the accuracy of your AI models because they're only reasoning from high-signal, clean context. The sources project that monetizing correctly curated, clean, dark data is going to be a $50 billion opportunity by 2028.
So this all sounds incredibly logical. It sounds like a massive, necessary digital decluttering, like the Marie Kondo of enterprise architecture. But practically, human to human, I keep going back to the psychology of it, how do you convince a nervous chief data officer whose entire career and perceived corporate power is built on acquiring and hoarding massive amounts of data to actually press the delete button on 60 zettabytes of company history?
If we connect this back to the bigger picture of enterprise management, you don't actually have to press delete immediately. You practice what the industry calls defensible deletion paired with aggressive tiering.
Defensible deletion. Walk me through the mechanics of that.
Platforms like Comprise use something called transparent move technology. You identify the cold, dark data, say, files that haven't been touched in 3 years. Instead of deleting them, you automatically tier them down to incredibly cheap archival storage tiers, like Amazon S3 Glacier.
Okay, so it's out of sight but not gone.
Right. Glacier is literally designed for data you never intend to look at. It's stored on magnetic tape in a vault, basically. Moving it off the expensive, high-performance primary storage saves massive amounts of money and drastically reduces the energy and carbon emissions required to keep it spinning.
But the chief data officer is happy because it's technically not deleted yet.
Correct. It is tiered, and the platform leaves a tiny symbolic link, like a shortcut, behind on the primary network. If a user ever actually clicks that shortcut, the file is automatically retrieved from Glacier. But here's the trick. Once it is tiered, you monitor it.
Right.
When you can definitively prove to the chief data officer that a specific subset of files has been sitting in cold tiering for 3 years, and that symbolic link has literally never been clicked a single time by any employee or any AI agent.
Then you can defensively delete it. You have the hard, empirical, undeniable proof that it possesses zero value to the organization. The insight has fully perished.
Exactly. You prove it isn't needed through data, not opinion. And you move the organization step by step toward a minimalist corporate footprint. You achieve DRAM's functional clarity without triggering the executive hoarding anxiety.
That is a truly elegant mechanical solution to a massive, messy psychological problem. We have covered an immense amount of ground today on this deep dive. Let's do a quick recap of the journey. We started by looking at the brutal physics of the cloud. We shattered the myth of weightless data and examined the thermodynamics, the massive CRK units, the megawatt power draw, and the aviation industry-sized carbon footprint required to power and cool 60 zettabytes of data we never use.
And then we examine the psychological hoarding instinct that tells us to save everything, leading to data silos in industries like healthcare, leaving 80% of their files as unstructured, unmapped noise.
We then quantified the active asymmetric threat, the $5 million unmapped breach risk caused by PII hiding in the dark, and how that leads to massive regulatory fines from frameworks like GDPR and HIPAA when hackers find the forgotten backdoor.
We looked at the AI collision, how feeding dark data to autonomous agentic AI results in massive token inferencing bills and hallucinating models. It's throwing rusted screws into a jet engine.
And finally, we detailed the cure, applying DRAM's less but better philosophy through automated tools, digital platform conductors, Comprise metadata extraction, and Prasad Bond's ruthless, elegant 48-hour time-to-live purge protocol to achieve defensible deletion.
It's all about functional reduction.
And here's why this matters to you, listening right now. Because whether you are a VP of infrastructure managing a multi-cloud enterprise architecture for a Fortune 500 company, or you are just a person looking at your own messy personal hard drive full of blurry photos and old PDF downloads, the principles of DRAMs apply perfectly. Less, but better. Functional clarity. Removing the non-essential burden leads to faster, cheaper, and more secure systems in every aspect of life.
It is entirely about taking control of your environment, rather than letting the artifacts of your environment control you.
Which brings me to a final, provocative thought for you to mull over as we end this deep dive. We just spent an hour talking about the massive cost and the immense risk of the 55% of data that is dark. But I want you to think about the 45% that isn't, the real value, the actual signal. If 55% of your digital footprint is just invisible, dormant, heavyweight, what incredibly valuable insight, what massive personal or professional breakthrough is currently being crushed underneath all that noise, just waiting for you to clear the clutter so you can finally see it?
It is a profound question. The signal is absolutely there, but you have to silence the noise to hear it.
At the beginning of this deep dive, we talked about looking at a murky X-ray, trying to find the shape of the problem in diagnostic muddy waters. Hopefully today we've helped clear the image for you. We've shown you that the real disease isn't the data itself, but our psychological refusal to let it go. We want to thank you so much for joining us on this deep dive. Keep questioning the information and the data around you.